गुड मॉर्निंग एव्हरीवन. आजच्या लेक्चरमध्ये आपण मल्टिप्लिकेशन ऑफ मॅट्रिक्स हा नवीन टॉपिक शिकणार आहोत. दोन मॅट्रिक्सचे मल्टिप्लिकेशन कसे करायचे ते आपण बघूया. मल्टिप्लिकेशन ऑफ मॅट्रिक्स A and B is possible only if number of column of first matrix is equals to number of rows of second matrix. जे पहिल्या मॅट्रिक्सचे कॉलम आणि दुसऱ्या मॅट्रिक्सचे रोज जर सेम असतील तर आपण दोन मॅट्रिक्सचं मल्टिप्लिकेशन करू शकतो. अदरवाइज मल्टिप्लिकेशन नॉट पॉसिबल. मॅट्रिक्स A is given of order 3 by 2. मॅट्रिक्स B is given of order 2 by 3. आपण या पद्धतीने लिहूया. 3 by 2 चा एक मॅट्रिक्स आणि 2 by 3 चा दुसरा मॅट्रिक्स. तर ही व्हॅल्यू आणि ही व्हॅल्यू सेम आहे. म्हणजे column of first matrix is equals to row of first matrix. Therefore AB exists. आणि नवीन जो मॅट्रिक्स मिळेल त्याची ऑर्डर असेल 3 by 3. हे उरलेले एलिमेंट. Now matrix X is of order 3 by 2 and matrix Y is of order 3 by 3. So for XY, write down here the orders of matrix, and if we observe this, these two values are not same. So we can write it as XY not exist. XY not exist. We cannot multiply the matrix X and Y. Now let us understand all these things by using the example. See the first example. Matrix A is given, matrix B is given. We need to show that AB is a null matrix. For this, first we will see whether the matrix multiplication is possible or not. So, order of new matrix. For that we write down these two matrix like this. See, the column of first matrix and the row of second matrix are same. So, AB exists. First we will write AB exists. And then the order of new matrix is this 2 into this 2. So, the order of new matrix is 2 by 2. So, after writing A into B, we need to write down the elements of the new matrix in the row and column form. Elements in the row and column form. See, if it is a 2 by 2 matrix, this is first row, second row, first column, second column. So, first position will be first row and first column. This position will be again, this is of first row and second column, so R1 C2. For third, this is second row and first column, so R2 C1. This is again second row and second column, so R2 C2. In this way, we need to write down the positions of the element. Because we are going to find it out separately, so we have to write it like this. For R1 C1, see, I have marked like this. In the first matrix, I have marked the rows, and in second matrix, I have marked the columns. In this way, we are going to multiply like this. See, first element into the first element plus second element into the second element. This is the answer for R1 C1. Let us write this. Now, 4 into 2 in bracket plus 2 into minus 4. Solve this. 8 minus 8 is equals to 0. Now for R1 C2. For R1, so we'll take this row 1 and second column. Multiply this. So what we are going to do is 4 into 6 plus 2 into minus 12. So write down here 4 into 6 plus 2 into minus 12. This way we are going to write. Solve. That is 24 minus 24. Answer is 0. Next is R2C1. Next is R2C1. For R2C1, we are going to multiply this second row and first column. So 8, this 8 into 2 plus 4 into 4. Write down over here. 8 into 2 plus 4 into minus 8 2s are 16 minus 4 4s are also 16. Answer is 0. Now for R2C2, we are going to take this first row and second column. Like this, 8 into 6 plus 4 into 12. So write down over here, 8 into 6 plus 4 into this minus 12. So this is 48 minus 48 is equals to 0. If we write down all the values over here, we observe this is the matrix of 2 by 2 and all elements of this matrix are 0. So this shows that AB is a null matrix. This only we have to find out. So this was the first example. Now let us go for second example. If the matrix A and matrix B is given, we need to find out A into B. For this, first write down the order of AB like this, and when we observe that the column of first element is equals to the row of second element, second matrix is same. So the order of new matrix is 2 by 2 and AB exists. Again, we need to write down matrix A into matrix B. After writing, just mark the column rows of the first matrix and the columns of the second matrix so that we can solve it. And as we know, the new matrix is of order 2 by 2. Write down its element R1C1, R1C2, R2C1, R2C2. Find it out. For R1C1, we are going to multiply each element of row 1 and column 1. So 3 into 2 plus 4 into 3 plus minus 2 into 0. Solve this. 6 plus 12 plus 0, that is 18. Now for R1C2, again this first row and second column we are going to multiply. Write down here 3 into minus 1 plus 4 into 4 plus minus 2 into 2. Write down answer minus 3 plus 16 minus 4 and the answer is 9. We solve this, we get 9. And 16 minus 7 is 9. R2C1. For R2C1, take second row and first column. So first element into first element, second element into second, and third element into third. Write this way. 2 into 2 plus 1 into 3 plus 0 into 0. So the answer is 2 into 2, 4 plus 3 plus 0 is equals to 7. For R2C2, again we are going to take this second row and second column. For second row and second column, multiply each element. 2 into minus 1 plus 1 into 4 plus 0 into 2. Write down the answer. It is minus 2 plus 4 plus 0. The answer is 2. So after replacing the R1, C1, R1, C2, the elements will get 18, 9, 7. We'll write down 9 properly. So this is a required matrix AB of order 2 by 2. We'll go for one more sum. If matrix A, B, C are given, we need to show that AB is equals to AC. Order of, for that first we'll see the order of AB. The rows and columns are same. So the new order also 2 by 2. Write down here matrix A into matrix B. Mark the rows of first matrix and column of second matrix. After that, write down the positions of resulting matrix of 2 by 2. Then multiply. See, again the elements of first row into the first column for R1, C1. First row and second column for R2, C2. Sorry, R1, C1. Second column and second row and first column for R2, C1. Second row and second column for R2, C2. Like this, we are going to do first this into this. Write down 2 into 2 plus 2 into 4. That is 4 plus 8. Answer is 12. Now we are going to multiply this first row and second column. So 2 into 3 plus 2 into 5. So 2 3s are 6 plus 2 5s are 10. So answer is 16. For this R2C1, we are going to multiply this second row and first column. So 2 into 2 plus 2 into 4. 2 into 2, 4 plus 2 into 4 is 8. Answer is 12. Now again, we are going to multiply this second row and second column. So 2 into 3 plus 2 into 5. So 2 3s are 6, 2 5s are 10. So answer is 16. If we replace the values of the matrix, we'll see that 12, 16, 12, 16. This is matrix AB. We need to find out matrix AC also. So for matrix AC, we have to find out first whether AC is possible or not. So write down order of matrix A and matrix B. The rows and the columns are same, so resulting matrix is of 2 by 2. First, write down matrix A into matrix C. Mark the rows and the columns, this way, and then write down the position matrix of AC, 2 by 2. This is the position matrix. We know for R1C1, we are going to multiply first row and first column. So do that. 2 into 4 plus 2 into 2. 2 into 4 is 8 plus 4. Answer is 12. Now we need to find out R1C2. So this is first row and second column we are going to multiply. So we'll do 2 into 5 plus 2 into 3. That is again, 2 into 5 is 10 plus 2 into 3 is 6. So answer is 16. Next is R2C1. R2C1. For this R2C1, we are going to multiply second row and first column. Second row and first column. So let us go for second one. So 2 into 4 plus 2 into 2. So that is 8 plus 4 is 12. Now we are going to multiply second row and second column. So 2 into 5 plus 2 into 3. So 2 into 5 is 10. 2 into 3 is 6. So 16. So we get the value 12, 16, 12, 16. And if we observe the value of matrix AB and the value of matrix AC, we see that matrix AB is equal to matrix AC. So from equation 1 and 2, we can write it as matrix AB is equals to matrix AC. So AB is equals to AC. Now we'll go the multiplication of matrix 3 by 3. In the same way we are going to do. If matrix A is given of order 3 by 3, prove that A square is equals to I. We are going to multiply the same matrix. So its column of first matrix is equals to row of second matrix. So A square exists. So write down A square is equals to A into A. After writing these two matrix, mark the rows of the first matrix and the columns of the second matrix. Then write down its position matrix of 3 by 3. We know how to write down the position matrix. First row, first column. First row, second column. First row, third column. Like this, write down all. And now multiply this. So first row and first column elements. So 0 into 0 plus 1 into 4 plus minus 1 into 3. Answer is 0 plus 4 minus 3. 4 minus 3 is 1. Now R1 into second column. So again 0 into 1 plus 1 into minus 3 plus minus 1 into minus 3. 0 into 1 0. 1 into minus 3 minus 3. Minus 1 into minus 3 is plus 3. So the answer is 0. Next, first row into this third column. Again 0 into minus 1 plus 1 into 4 plus minus 1 into 4. So we get 0 plus 4 minus 4 is equals to 0. Now we'll start with the second row. So for R2C1 we need to take second row and first column. Multiply all this. So we'll write it here. 4 into 0 plus minus 3 into minus 3 into 4 plus 4 into 3. So 4 into 0 is 0. This is minus 12. This is plus 12. So again this is plus 12 minus 12, 0. For R2C2, take this second row, second row of first matrix and second column of second matrix. So 4 into 1 plus minus 3 into minus 3 plus 4 into minus 3. Let us solve this. 4 into 4, 4 plus 9 minus 12. 4 plus 9 is 13 minus 12 is 1. R2C3, second row and third column. So we'll write down here 4 into minus 1 plus minus 3 into 4 plus 4 into 4 is equals to minus 4 minus 12 plus 16. Minus 4 minus 12 is minus 16 plus 16 is 0. Now we are going to start with the third row. So we will mark third row, and for this position we need to multiply third row and first column. So multiply this. 3 into 0 plus minus 3 into minus 3 plus not minus 3. First we are going to take no. So minus 3 into 4 and 4 into 3. 0 minus 12 plus 12 minus 12 plus 12 0. For R3C2 third row and second column. So we'll multiply 3 into 1 plus minus 3 into minus 3 plus 4 into minus 3. 3 into 1 3 minus minus plus 3 into 3 9 minus 12. So 3 plus 9 plus 12 plus 12 minus 12 again 0. Now we are going to multiply third row and third column. So 3 into minus 1 plus minus 3 into 4 plus 4 into 4. This is minus 3, this is minus 12, minus 6, plus 16. 4 plus 4, 16. Now this is minus 15 plus 16 is 1. If we arrange these positions, we will get this matrix of 3 by 3. And if we observe this matrix A square, this is a identity matrix. Therefore, we can write down A square is equals to I. And this is our required answer. This way, we can multiply any orders of matrix. Thank you.